All right, in this video, we'll take a look here at example number 3. Can I determine with justification whether this series converges or diverges? So again, I'm going to try to do the exact same steps that I did before. And I'm going to check to see if first this is alternating. Let's see what we have. I definitely have -1 to a power. That's going to be, alternating from -1 to positive ones. And the rest of the stuff that I have in there, 3n minus 1 over 2m plus 1, that's definitely always going to be positive when I plug in numbers 1 and larger. So I definitely have an alternating series here. Let's just see if we can meet those checks like we did before. I need to check to see if this is a decreasing a sub m and if its limit goes to 0. So I'm going to start by at least writing this. We see that a sub n is equal to 3n minus 1 over 2n plus 1. Now I'm actually going to ask you to check this time. Can we do check number 2 first? I would like you to really quickly go ahead and attempt to calculate out this limit. I'm curious what it is that you end up with. I'd ask you really quickly to go ahead and pause the video so you can go ahead and compute this and then check the answer once you're done. Okay, so an answer that we could end up with here, if I went through and I divided, oops, it's kind of strange. There we go. If I multiplied everything by a 1 over n on top and bottom, I could easily see that this turns into 3 minus a 1 over n over 2 plus a 1 over n, and that just turns into 3 halves. Now, last I checked, that is not 0, so we got a problem here. Are we going to be able to meet the criteria necessary to use the alternating series test? No, it doesn't seem like we are, because we're supposed to get equal to 0. Now I have to also be a little careful here, because there have been some other times where I've written down that we've taken a limit and we've not gotten 0. If when I wrote that, it maybe popped into your mind, oh, maybe we could use test for divergence, be a little bit careful. Test for divergence says you would have to do the limit of the entire inside thing. And we didn't do the entire inside formula, we only did a part of it. So we can't even use test for divergence at this point. Well, this is kind of frustrating. What I could do is I could go back up and say, all right, great. What does the alternating series tell me happens when I don't meet the conditions? If I'm not meeting condition 2, what does the alternating series test say should happen? What does it say? Read it right off the box. Okay, hopefully you are realizing the alternating series doesn't tell you anything about what happens if those 2 conditions are not met. It doesn't tell you a thing. It's very tempting to say, oh, if I don't meet the conditions, then it's divergent. Well, maybe, but also maybe it's convergent. I mean, how do we know? So what we have to be very careful of here is recognizing that the alternating series only helps if I meet the conditions. And again, if I don't meet the conditions, the test doesn't say a thing. So what exactly then are we supposed to do with the question like this? Because I'll notice I can't actually use like hardly any of the other things that we've looked at on this kind of summary page. It's not any of the other types of series. I can't do like a limit comparison test because I have negative things. I can't do a comparison test because I have negative things. I can't do an integral test because I have negative things. Well, then that looks like there's only one test left. And maybe it is the test for divergence. Let's take a look and see how the test for divergence could actually be useful here. Again, since I have things that are going to be alternating between negative and positive items, and I can see that the limit of that stuff turns to 3 halves without the negative, then I might be able to argue the following. First, I'll write here, just as a quick reminder, we see that alternating series test does not apply. All right, so here's how I might be able to proceed, and you might recognize this from when we looked at things back in 5.1. Here's what we could say. So I'll word it like this. If we observe even numbered terms from the series, we see that the limit as n approaches infinity of -1 to the n over 3n minus 1 over 2n plus 1, if I'm dealing with even numbered terms, that's n being even, then really I can see what happens to that -1 to an even power. Well, that's always going to be positive, right? So I'm going to just be able to reduce down to this, and we already said the limit of this is 3/2. But for odd number terms, we see that the limit as n approaches infinity of this entire inside formula is actually, again, if n is an odd number, I'm going to have -3n minus 1 over 2n plus 1. And the limit of that is -3/2. And now I can reach a conclusion. Since the odd and even terms approach different values, we can say that the limit as n approaches infinity of the entire inside formula, 3n minus 1, does not exist. And by, I'll abbreviate here, by test for divergence, the series diverges. So this is a really surprising result that we kind of come across. It's actually totally possible to use tests for divergence. It's kind of the only other possible test that we could use when I come across an alternating series that doesn't appear to meet the appropriate conditions. We can kind of see here how that actually played itself out. Notice, checking to see right now whether or not the original a sub n that we wrote up here was decreasing wouldn't have really mattered. So sometimes I'll often suggest that you actually check the second condition first, because sometimes you can do it fairly quickly in your head. And if you recognize that you're not getting a 0, you maybe know to try to switch gears and do the limit of the entire inside. And that way you can see how test for divergence plays out. Okay, in the next video, we'll take a look at another theorem and an associated example.